Okay. Omitted subchapters 4.6, 4.7 and 4.8. Okay, these chapters are omitted. Okay, so I'll start now from the 4.9, which is the indeterminate forms. Okay, and sometimes we have some indeterminate forms, and we will apply, for example, the very popular indeterminate forms as the limit x equals to 0 sine x over x. Okay, this is a very popular indeterminate forms, and we know that it's equal to 1, but okay, we will use some indeterminate forms like 0 over 0, infinity over infinity, and 0 times infinity, like that. Okay, I will give all of the types and the examples about these indeterminate forms, of course, but I want to say when you see like these indeterminate forms, okay, you can apply the L'Hopital rules, okay, for these types forms. Okay, and let me give you what is the L'Hopital rule. Okay, suppose the functions f and g are differentiable along the interval okay a comma b open interval and g prime of x does it equal to 0 dash. Okay, and suppose also that limit x equals to a from right hand side f of x equals to limit x equals to a from right hand side, okay, g of x equals 0 and limit x equals to a from right hand side f prime of x over g prime of x L, where L is finite or infinity or minus infinity. Then we can say limit x equals to a from right hand side, f of x over g of x equals to L. And we can say similar results hold if every occurrence of limit x equals to a from right hand side is replaced by from limit x equals to b from left hand side, or even limit x equals to c, where a is less than c is less than b. The cases a equals minus infinity and b equals plus infinity are also allowed. Okay, you can find the proof of this definition of the L'Hopital's rule in your book, and let me give you some indeterminate forms, okay, and some examples of them, okay, and type an example. Zero over zero. Limit x equals to 0. Sin x over x. Okay. And infinity over infinity. Limit x equals to 0, okay, ln of 1 over x square over cot of x square, and the 0 times infinity. Also, it can be written infinity times 0, of course. Limit x equals to 0 from right hand side, okay. X times ln of 1 over x, okay, and the infinity minus infinity, okay. Limit x equals to pi over 2 from left hand side, okay, tangent x minus 1 over pi minus 2x, okay, and also 0 to the power of 0, okay, and the example for this indeterminate form, x equals to 0 from right hand side, okay, and of course x to the power of x. And another popular indeterminate form, which is the infinity to the power of 0, okay, and the example for that, limit x equals to pi over 2 from left hand side, and the tan x to the power of cosine x, okay, and the last one 1 to the power of infinity, and it's the limit x equals to infinity, okay, and the 1 plus 1 over x to the power of x. Okay, now what will we do when we evaluate like these limits? Okay, and of course we will apply the L'Hopital rules for that, and let me give you for firstly infinity over infinity, okay, and after that I'll continue such as these indeterminate forms. Example, limit x equals to pi over 2 from left hand side, okay, tangent x over 1 plus tangent x, okay. We know that, okay, firstly reminder, and the tangent x equals to, we know that sine x over cosine x, okay. When you approach to the pi over 2, okay, from the left hand side, that means the less than some values, okay, pi over 2 of course, and the sine x will approach to 1, okay, and the cosine x will approach to 0, like that, and I think it will be the infinity, okay, and don't forget infinity, and of course if it is infinity, so we can say infinity plus 1 will be infinity, so this will be infinity over infinity, okay. So it's indeterminate forms, and what will we do? We will apply the L'Hopital rule, and the L'Hopital rule says us derive the numerator part and the denominator part of the limit, and the limit x equals to pi over 2 from left hand side, okay. Derivation of tangent x, we know that it's the secant square x, right, and the denominator part will be same, secant square x, so it's equal to 1, okay. And as you see, here is L'Hopital's rule used, okay. And another example, let me give you. Limit x approaches infinity, x minus 2x squared over 3x squared plus 5, okay. And of course the numerator part will be minus infinity because of the biggest degree of the polynomial function is x squared, so the x squared sign is negative, so the numerator part will be minus infinity, and the minus infinity over the denominator part will be positive, so it will be the plus infinity. So nothing changed, okay, only sign will be changed, and we can say now apply the, okay, L'Hopital rule again, and the limit x equals to infinity, and the numerator part will be 1 minus 4x, and the denominator part will be 6x, right, and after that it's equal to minus infinity over plus infinity again, okay, and here is L'Hopital rule, okay, and again the L'Hopital rule, okay, twice, okay, and maybe 3 times, maybe 4 times, okay, you can apply this rule again and again, okay, and after that limit x equals to infinity, okay, and the minus 4 over 6, so it's equal to minus 2 over 3, which is the result, okay. And now don't forget this sentence. If you evaluate 0 times infinity and okay, infinity minus infinity, okay, forms, you can convert this type or these forms, okay, to 0 over 0 or infinity over infinity, okay, forms first, and then L'Hopital rule will be applied. Okay, example. Limit x equals to 0 from right hand side, okay, and the x times cotangent x, it equals to 0 times infinity, okay, we know that, and the here is L'Hopital rule, okay, and we can say limit x equals to 0 from right hand side, okay, we can use this part, okay, x over tangent x, because of we know that cotangent x equals to 1 over tangent x, okay, we use this equality, and after that our indeterminate forms, okay, converted to the 0 over 0 as you see. And after that, I'm sorry, this here is no L'Hopital rule, here is conversion, okay, conversion. And after that, we can now use the L'Hopital rule because we evaluated the 0 over 0 indeterminate forms. And after that, limit x equals to 0 from right hand side, and we know that the x derivation will be 1 and the tangent x derivation equals to secant square x, okay. And after that it will be 1. Okay, and let me continue with another example, which is about the infinity minus infinity, maybe infinity plus infinity, okay, it's not important, and we must convert this type forms, okay, to the infinity over infinity type, okay, don't forget it. And the limit x equals to 0, 1 over sine x, okay, and the minus 1 over x. As you see, this is the minus infinity indeterminate forms, okay, and all of them, okay, and the right hand and the left hand limits are important, okay, don't forget it, but okay, these types is very critical limit, okay, let me write it. The right hand and left hand limits are important. What I mean, okay, look at it, limit x equals to 0 from right hand side, okay, and the 1 over sine x, okay, and it will be, okay, 1 over 0, okay, this is plus sign, that means the 0.000001 or 2, etc., okay, that means the positive, okay, and this part will be plus infinity, and the limit x equals to 0 from left hand side, okay, and the 1 over sine x, okay, and that means it will be 1 over 0 negative, that means it will be minus 0.000001, okay, so it will be minus infinity, okay, these are different. And the same idea when limit x equals to 0 from right hand side, okay, and the 1 over x, what will it be? It will be plus infinity, of course, and the limit x equals to 0 from left hand side, and the 1 over x will be minus infinity. So what can we say about it? Okay, we can say, okay, when you use these two hand-sided limits, okay, and then you can say that totally limit x equals to 0 from right hand side, okay, and the 1 over sine x minus 1 over x, okay, that's equal to infinity minus infinity, right? And after that, limit x equals to 0 from left hand side, 1 over sine x minus 1 over x, okay, that's equal to, and this part will be minus infinity, okay, and the another part is the minus infinity, so it will be plus infinity. So, okay, from both sides, okay, we have just evaluated, okay, infinity minus infinity totally. So we must convert this indeterminate forms to the 0 over 0 forms, okay, and or infinity over infinity. Okay, limit x equals to 0, okay, and look at it. When you multiply by the denominators part of both of the equality, you will obtain the x minus sine x over x times sine x, okay, and so it's equal to, we know that 0 over 0, and after that let's use the L'Hopital's rule, okay, and what will we obtain, what will be evaluated, okay, and the x equals to 0, 1 minus, okay, cosine x over sine x plus x cosine x. So it's again 0 over 0, okay, and again apply L'Hopital's rule, okay, and the limit x equals to 0, and the numerator part will be sine x and over two cosine x and the minus x times sine x, okay, and with 0 over 2 minus 0, so it's equal to 0, okay. L'Hopital's rule and the forms one to the power of infinity, 0 to the power of 0, and infinity to the 0, okay. If any of the above occurs, what will you do? We will kill them, okay. And then calculate the limit of the logarithm first and exponentiate the limit afterwards. Okay, and let me explain that. Suppose that limit x equals to a, f of x it equals to 1 to the power of infinity or 0 to the power of 0 or infinity to the 0. Okay, first step, limit x approaches to a, okay, ln of f of x, it equals to L, okay, and the second step, limit x approaches to a, f of x, it equals to limit x approaches to a, okay, e to the ln of f of x, okay, it equals to e to the power of L, okay. Okay, don't forget these types, okay, the steps, and the example show that limit x approaches to 0 from right hand side, okay, and the 1 plus x to the power of 1 over x, it equals to e, okay, it equals to 1 to the infinity, okay, what I mean, okay, firstly, okay, let's take this part like f of x, okay, and what was the first step, okay, ln of f of x, okay, and that means, okay, 1 over x times ln of, okay, 1 plus x, right, and the limit, okay, x approaches to 0 from right hand side, okay, ln of f of x, it equals to limit x approaches to 0 from right hand side, okay, ln of 1 plus x over x, right, and we know that it's the 0 over 0, so we can evaluate, we can apply the L'Hopital rules, and after that it will be limit x approaches to 0 from right hand side, and the 1 over 1 plus x and over 1, okay, and this part will be 1, which is the capital L value, okay, don't forget it, this value is L, okay, and after that use the second step, limit x approaches to 0 from right hand side, okay, and the ln, oops, yes, and the f of x, it equals to limit x approaches to 0 from right hand side, okay, e to the ln of f of x, okay, and it's equal to limit x approaches to, okay, x approaches to 0 from right hand side. We know that it's equal to, let me write it, and it will be, this part was 1, so e to the 1, so it's equal to e, okay? And the again, I'll give you another example. Find limit x approach infinity x to the power of 1 over x. That means, okay, infinity to the power of 0, okay? And the solution, firstly, we know that f of x equals to x to the power of 1 over x, right? And after that, ln f of x, it's equal to, okay, ln x to the power of 1 over x, which is equal to 1 over x times ln of x, okay? And after that, limit x approach to infinity, okay? And the ln x over x, okay? And it will be the infinity over infinity, okay? And they apply the L'Hopital rule, okay? What will obtain? 1 over x over, I'm sorry, firstly I have to write the limit x equals to infinity, okay? And this part is 1 over x over 1, so it's equal to 0, okay? And which is limit L value, capital L value. And the second step, limit x equals to infinity, okay? And the f of x, it's equal to limit x equals to infinity e to the power of, okay, ln f of x, okay? And then we know that it's equal to 0, e to the 0, so it's equal to 1. Okay, and let me give you another type example. Popular one is limit x equals to 0 from right hand side, x to the power of x, okay? And we know that it's equal to 0 to the power of 0, but if you take f of x like x to the power of x, so ln f of x equals to, okay, x times ln of x, right? And after that, limit x equals to 0 from right hand side, okay? And the x times ln x, okay, it's equal to 0 times minus infinity, okay, indeterminate forms. And after that, okay, when you convert these type integrals to the infinity over infinity, that means ln of x over 1 over x, okay? Now it's equal to minus infinity over plus infinity, and apply the L'Hopital rule, and after that limit x approach to 0 from right hand side, and this part will be 1 over x over, okay, and the minus 1 over x square, and the limit x approach to 0 from right hand side, okay, and this part will be minus x, and it's equal to 0, which is the capital L value. And the second step, limit x equals to 0 from right hand side, f of x is equal to e to the power of 0, which is equal to 1. Don't forget, okay, don't forget the second step. If you forget this step, okay, you will evaluate, okay, you will say, yes, this limit is 0. But if you don't use the second step, okay, you can't find the exact result, okay? Because of this result is not 0, it's 1, okay?